The topic of this video is finding the horizontal or oblique asymptote of a rational function. Let's look at a problem. Capital Q of x is equal to the rational function whose numerator is x cubed minus 8 divided by the denominator of x squared minus 7x plus 10. Okay, so the first step in finding the horizontal or oblique asymptote of a rational function is to determine the degree of the numerator and the degree of the denominator and compare them. So we look up here. We see that we have a polynomial in standard form, which means the highest exponent of x tells us the degree. So this is degree 3. Similarly, this is also in standard form, and its degree is 2. So now we compare, and we see that the numerator polynomial degree is greater than the denominator polynomial degree. But by how much? Well, 3 is more than 2 by 1. So that means that we are dealing with case C. Let's read case C out loud. If the degree of the numerator polynomial is 1 higher than the degree of the denominator polynomial, then use polynomial long division. If there is a remainder, then the quotient discarding the remainder is the oblique asymptote. All right, so we need to set this up as a long division problem. Let's go ahead and do that. All right, so over here, I'm going to write my numerator, x cubed minus 8. Notice there are two term types missing, which would be the x squared and the x. Both of those have to be included in the problem. So I've written plus 0x squared plus 0x in between the x cubed and the minus 8. And our denominator, also known as the divisor, is going to go out here to the left. Okay, whenever you perform polynomial long division, you should always create your columns before you start the process. So just to the left of the add or subtract signs, we're going to put these vertical lines, which will create our columns for our problem. This will be our x cubed column. This will be our x squared column, this will be our x column, and this will be our number column. Okay, with that we are now ready to begin polynomial long division. Here's the way it works. You take the first term of the lowest under, and you divide it by the first term of the denominator. We're going to do this in our side workspace. So we have x cubed divided by x squared, which is x. That x represents the first piece of our quotient. And therefore, it goes above the division bar in the appropriate column. In this case, it goes in the x column because this is x to the first power. This column is for terms that have x to the first power. Okay, next we take that piece of our quotient and multiply it by our entire denominator, x squared minus 7x plus 10. And we use the distributive property to do that. And we get x cubed minus 7x squared plus 10x. This result goes underneath our division bar, lining up the columns. So we put the x cubed here, we put the minus 7x squared here, we put the plus 10x here. The next step is to subtract. To do that, we're going to use the rhyme. So we will draw the line, underlining the newest terms we've just placed, change the sign of all the terms that we just placed, then combine vertically. X cubed negative x cubed combine to make 0. 0x squared plus 7x squared is 7x squared. 0x minus 10x is minus 10x. And bring down all terms that have not yet been changed in your polynomial long division problem and start the process over again. All right, so we have first term of the lowest under, which in this case is 7x squared, divided by the first term of the denominator. We will once again do this in our side workspace. So we have 7x squared divided by x squared, which gives the result 7. This is the second piece of our quotient. And because it's just a number, it goes in the number column. Because it's positive, we'll write it as plus 7. Next, use this most recent piece of your quotient and multiply it by the entire denominator. With the distributive property, we get 7x squared minus 49x plus 70. This is placed underneath the lowest under in the appropriate column. So the 7x squared will go in the x squared column, and we work our way across. All right, now say and perform the rhyme. Draw the line, change the sign, then combine. So 7x squared and negative 7x squared combine to make 0. Negative 10x plus 49x makes positive 39x. Negative 8 subtract 70 is negative 78. All right, we notice now that the exponent of our x is 1, and the exponent of the x here is 2. And because 1 is less than 2, we stop. This is the end of our polynomial long division problem. This 39x minus 78 is the remainder. We'll label it that way. And this x plus 7 up here is the quotient. All right, and we are now ready to create our final answer for this problem. Let's once again read what it says in case C. If the degree of the numerator polynomial is 1 higher than the degree of the denominator polynomial, then use polynomial long division. Done. If there is a remainder, then the quotient discarding the remainder is the oblique asymptote. So, did we get a remainder? The answer is yes. Therefore, we will have an oblique asymptote, and its equation will be y equals the quotient, which in this case is x plus 7. And with that, we have completed this problem.